Hello and welcome to our lesson on solving quadratic equations using the factoring technique, which technically will be reviewed for us, and then using the square root method. Okay, so just to recap a little bit, what does it mean for an equation to be a quadratic equation? Well, it means that it has a degree of 2. So a polynomial equation is considered quadratic when it has a degree of 2. So it's got an x squared in it. And why is that important? Well, the degree is important because it shows us the number of possible solutions. So when we're solving a linear equation or an equation with a degree of 1, we're looking for one possible solution. If it's got a degree of 2, if it's quadratic, 2 possible solutions. If it was a degree of 3, if it was cubic, then it would be 3 possible solutions, and so on. Okay? Now, the solutions to quadratic equations can vary. It's 2 possible solutions, but it's possible that we get 1 solution. And then the way the solutions look can definitely vary depending on what kind of quadratic equation we're looking at. So I have a few basic quadratics here that really, like the first one, 2 of these maybe, you should be able to tell me the answer without really even knowing how to solve. So for instance, when we're looking at x squared equals 4, what number can we square to make 4? Well, definitely 2 squared makes 4, but also negative 2 squared makes 4, right? So technically, here, where you could say x could be equal to a positive or a negative 2. So 2 solutions there. And what we're doing technically to solve an equation like this is, in our head when we ask ourselves what number squared makes 4, we're really looking for the square root of 4. And that's precisely the operation that would undo the square, right? If I took the square root of both sides, the square root of x squared would leave me x to the first, and the square root of 4 technically is 2. But since we're not really just looking for the square root of 4, because we're looking for what number squared makes 4, it's going to be a positive and a negative 2. Okay? So the same concept we could apply here. Here, what number squared is going to make 5 is not going to be perfect, but if I were to square the square root of 5, I would get 5. If I was to square the square root of negative square root of 5, I would get 5 as well. So this would be plus or minus a square root of 5. Again, a square root of 5 squared is going to make 5, and a negative square root of 5 squared is going to make 5. Okay? So 2 solutions on the first one that were 2 rational solutions. 2 solutions on the second one, but this time they're irrational numbers. Now let's look at the third one. What number can we square to make 0? Well, what number can I square to make 0? There's no difference between a positive or a negative 0, so even though there are 2 possible solutions in here, we just get 1. So that's going to be an option for us. 1 rational solution. And then here's the interesting one, okay? What number squared could we, or what number could we square to make a negative 4? Normally when we square a real number, right, we're not going to be able to square a real number and get a negative. But based on our previous topic, we know we can square something to get a negative, and that would be the imaginary. So here, what can we square? If we took the square root of negative 4, there's no real number value for that, but we can simplify that down to 2i. So if we squared a positive or a negative 2i, we will get to negative 4, right? 2i squared. 2i times 2i would be 4i squared, and that would make it a negative 4, and the same if it was negative. So solutions to quadratics can vary. There are 2 possible, and it's possible that those 2 are real and rational, that's what we have here. They could be real and irrational, that's what we have here, or they could be complex or imaginary. And then it's also possible that we just get 1 rational solution. Okay? So quadratic equations, before we get too in-depth here, we'll either have 2 real solutions. Okay, 2 real solutions happened here, 2 real solutions happened here. Some were just rational, the other 2 were irrational. We could also have 1 real solution, and that happened here. 1 real solution that happened to be rational. And then it's also possible that we get 2 either complex or imaginary solutions, and that's what we saw happen on this last one, the 2 imaginary solutions. And really, Even though there is a distinction between just imaginary or complex, remember all imaginaries are complex, they just have a zero real number part, but we're going to see those sort of used interchangeably, okay? So if you said two complex solutions or two imaginary, it would be okay in either case. Now, what we did technically to solve those four very simple equations was use what we call the square root method. We use a square root to undo the square. And if they were all that simple, I wouldn't have to show you anything, but obviously looking at like number one, not that it's too complicated, but we want to make that problem look like the previous four, where we have just an x squared and then some number over here, and then we can simply just square root to solve. So what we want to do to use this square root method is get the squared term, so this x squared, let's get that by itself, okay? Get the squared term alone. And that means, use inverse operations. So add the 1, divide the 2, or subtract if there's something's being added, divide if something's being multiplied, and so on. And then once the square root's all alone, we're going to get rid of, once the squared term is all alone, we're going to get rid of the square by taking the square root. And that's not going to fit there, so let's use the symbol. We're going to take the square root of both sides. And we got to be really, really careful on this step, because what that's going to leave us is just like the first problem. When we go to take the square root of both sides, we're going to have x equal to, if we were just looking for the square root of 4, the answer would be 2. But because we're really looking for what number squared is going to give us 4, we have to make sure that in the solving process, when we square root, we're going to put a plus or minus in front of the result. So we have to make sure to put a plus or minus in front of the number that you're taking the square root of, or in front of the result of the square root, okay? And then if necessary, we might still have to work on getting x alone, and we'll see some examples of that in a little bit, okay? And the nice thing about solving an equation is you can always check your work by plugging your answer in. So I'll show you how to do that with or without the calculator. All right, first example here. I want to make this look like the 4 problems I did a few minutes ago, so I'm going to get the squared term by itself. First thing I'm going to do is add 1 to both sides. That's going to give me 2x squared equal to 18. Now I'm going to get rid of this 2. It's being multiplied by the x squared, so I'm going to divide it, and that's going to give me x squared equal to 9. And now it looks just like it did before. So I'm looking for what number squared makes 9. If I square root both sides, I can see x is going to be equal to, well, remember the square root of 9 is 3, but what number squared makes 9 would be a positive or a negative 3. So those are our two real and rational solutions. Okay, same concept here. I'm going to subtract the 2 from both sides. And now we have x squared divided by 5 equal to negative 5. And now to get rid of division by 5, I'm going to multiply. So I'm going to multiply this side by 5, multiply this side by 5. That cancels those. And that leaves me x squared equal to a negative 25. Now we're going to square root to get rid of the square. Square and square root are going to cancel, so x is all by itself, and on the other side, I'm putting in my plus or minus every time I square root. And then what do we have for the square root of negative 25? So there's no real number value, but square root of 25 is 5, and the square root of negative 1 is going to be I. So we have two imaginary solutions here, or complex if you prefer. And that box was really bad. Sorry. Okay, there we go. All right, now, if you notice, number 3 looks a little different. We've got some parentheses in this problem, and you may be tempted to undo those parentheses, but we don't have to here. We can still use our square root method to solve. It's just our squared term looks a little different. Instead of just an x being squared, we have an x minus 5 being squared. That's okay. And just like getting the x squared by itself, we want to get the x minus 5 by itself. So we want to get the squared term alone, which means in this one, we are going to start by dividing the 3 that's outside of that squared term. So divide both sides by 3. And now I have my squared term, which is x minus 5 squared. I have it all by itself equal to a negative 9. Now I can get rid of the square by taking the square root. Let's take the square root of both sides. The square and the square root cancel from the left, leaving me the x minus 5. And on the other side, I got to put in the plus or minus. And the square root of negative 9 is going to be 3i. Okay, now in the two previous problems, after we took the square root, we were done because x was alone. But you can see here x is not by itself. There's still a minus 5 there, so I have to take one more step to keep solving. I have to add 5 to both sides. So x is going to equal. Now when I add 5 to the right, can I really combine the real number 5 with the imaginary numbers 3i or negative 3i? No, which means we're going to have complex solutions here. We're going to have a 5 plus or minus 3i that cannot be combined. So that's two solutions. I just have written them in condensed form here. This is saying that x could equal 5 plus 3i. That's one complex solution. And it's also saying 5 minus 3i is a second complex solution. So you got to recognize that there's two separate solutions there. But if you want to write them in condensed form, then that's perfectly acceptable. Okay? So 5 plus or minus 3i, two complex solutions there. And later on when we get to functions, you'll hopefully have a better understanding of why we have these different types of solutions. But for now, let's keep going here. I'm going to add 2 to get my squared term all by itself. Okay? So adding 2 to both sides cancels that out. That leaves me an x plus 1 squared equal to 22, and 2 is going to make 24. Now I'm going to take the square root of both sides. And so the square and square root cancel on the left, leaving me x plus 1 on the other side, plus or minus. Now radical 24 is not exact, it's not a perfect root like my other previous problems, but that's okay. I know how to simplify radical 24. So 24 is 2 times 12. And 12 is 2 times 6, which is 2 times 3, which means a 2 is going to come out of that radical, and a 6 is going to stay in. So this becomes plus or minus, instead of radical 24, 2 radical 6. And then I've got one more step to get x by itself. I'm going to subtract the 1 over. And these, again, not like terms. I can't really subtract 1 from a 2 radical 6. I can only add and subtract like radicals, remember? So the negative 1 is going to stay separate from the plus or minus 2 radical 6. So this is two irrational solutions. They're real solutions. They're ugly. They're irrational. And again, recognize that this is saying negative 1 plus 2 radical 6 is a solution, and it's saying that negative 1 minus 2 radical 6 is a solution. Now, if that's hard to wrap your brain around, it just means we have two decimal solutions, okay? So a negative 1 plus 2 square root, not pi, square root 6 is an answer, so approximately 3.9-ish, right? This is approximately 3.9 is an answer, and then negative 1 minus 2 radical 6 is an answer, so like negative 5.9. So approximately negative 5.9 is another answer. Okay, sometimes the answers aren't as nice as we would like them to be. All right. Hopefully so far we're feeling okay with this. And then remember, you can always check your work. It's not super easy to check when you have these imaginary or complex solutions, but definitely something like the first one. You know, if you wanted to check, you can plug in a positive 3. 2 times positive 3 squared minus 1 should equal 17. So that's 2 times 9, which is 18, and 18 minus 1 is definitely equal to 17. So those check out. If I put a negative here, I would still get a positive when I square, so both of those are going to work. Okay. Now, if it's a little uglier, you can still use, you can still plug it in to check. It's just you'd probably want to use the calculator. For example, on number 2, if you wanted to check 5i was a solution, you're going to put in 5, use the keyboard, and I. Let's see if Desmos can handle I. 5i squared. Let's divide by 5, and let's add 2, and see, nope, it doesn't like it. Okay, so we're not going to use Desmos to check if it's imaginary, but 5i squared, if we know 5i squared is going to be 5i times 5i, that's 25i squared, and I squared we know gets replaced with -1, so it becomes a -25. And -25 divided by 5 is -5, plus that 2 does make a -3. Okay, so we can't use Desmos for the imaginary, but you could use it for something ugly like number 4 here. Okay, number 4 we have these ugly solutions, but the calculator can handle those. It can handle the real numbers. So if I put in -1 plus a radical 6, and then after that a +1, and that quantity should be squared, and then I subtract 2, I should get 22. What did I do wrong here? Oh, I forgot the 2. Jeez, guys, I'm staring at this. I forgot the 2 in front of the radical 6. If you want to check your answer, you got to plug it in correctly. Okay, so you can see I replaced the x with this -1 plus 2 radical 6. Put the quantity in parentheses, squared it, subtracted 2, I got 22. And then if I just change this positive to a negative, then I get 22 again. So if it's an irrational solution, you can use your calculator to check. Now, for the most part, you don't need to check everything you're doing. Have some confidence that you're doing it correct, and you've got unlimited attempts in your practice, so it's not a big deal there. But if you're taking a quiz and it's worth a little more and it's not too big of a deal, check your work. Okay? And I think I just erased some stuff. What I did there. I don't know if I erased anything. I'm losing it, people. Some of you are like, well, you've never had it, so how can you lose it? I don't know. Okay, here's one for you to try if you're feeling like this process is okay for you. Good opportunity to pause the video and give it a shot. The rest of us, let's go here. Subtract 1. We want to get that squared term by itself. So that's going to give us x minus 3 squared equal to 16. And you know what? Just for fun, I'm going to alter this problem. I'm going to stick a 2 in here. I'm going to make this 2x minus 3 squared plus 1 equal to 17. Just so I'm sure we can handle this. So if you pause the video, you're going to come back and be like, well, what the frick? So, I'm sorry. I just want to make sure we can handle this extra step. So we still want to subtract the 1 over. We're still resulting in a 16. And then we're going to square root to get rid of that square. That's going to give us 2x minus 3 equal to plus or minus. The square root of 16 is going to give us 4. Now, we got to be really careful here. So if we look at the previous problems, after we took the square root with those parentheses, when we added and subtracted, we couldn't actually combine any like terms here. We couldn't actually combine any like terms here, and so we didn't have any issues just keeping those terms separate. But in this problem, in my next step, when I go to add 3, I can actually add 3 to 4 and -4, so I have to be careful because it's going to result in 2 separate numbers. So this is, let me just write this out for a second. This is 3 plus or minus 4, right? And again, these are actual numbers that I can put together, so I want to do that. So I'm going to make this 2x equal to, well, 3 plus 4. If I add the 3 and the 4, I get 7. And then 3 minus the 4, 3 minus 4 would be -1. So right now I have 2x equal to a 7 or a -1. So this could be 7, and then I'm going to put a comma. Let me back to blue. A 7, comma, -1. And then x is still not alone, which means I still have to divide by 2. So let me, green, divide by 2. And each of these options is going to be divided by 2 because technically over here, right, I could have just divided the whole side by 2. So here, Dividing by 2 makes that cancel, and I could see one of my solutions is 7 over 2, and my other solution is negative 1 over 2. And separating it with a comma like this is fine. Just make sure you're not confusing that with a coordinate. This is two separate solutions, x equals 7 halves and x equals a negative 1 half. Okay? Was I boxing over here? Yep, I was. So x equals 7 halves and negative 1 half. All right? And if you did the U-try and you didn't change the problem, sorry I did that to you. Okay. All right. Now, that's using what we call the square root method. The square root method to solve, I like the method. It makes sense. If you have a square in there, you take the square root. Now, that's not actually the first method we looked at for this course for solving a quadratic. We also have looked at solving by factoring. Well, solving by factoring, which again we're going to review, is going to be applicable for a problem like this. How come I can't just use the square root method again? Why did we learn this solving by factoring in the first place? Why couldn't I have just learned the square root method before? Well, think about this particular problem here, okay? If I wanted to use the square root method, get the squared term by itself, well, that would give me a negative 13x on this side and a negative 12 on this side. I have to subtract those terms over, right? Well, at this point, if I go to take the square root, can't really square root a negative 13x minus 12. And I don't want x equal to plus or minus something over here with an x in it. If you're solving for x, then x can't be part of your solution. Okay, there's got to be just number values, numeric values over here. So the square root method doesn't work here. And in fact, it's never going to work when you have a squared term and a term with an x to the first. So what you have in each of these previous problems was a squared term, and then everything else was a constant. Okay? If you look here, we had a squared term and then constants. Squared term, constants. So anytime you have a squared term and then everything else is just a constant that you can either add together, subtract together, divide to make one number, then you can use that square root method. But as long as you have a squared term and a term with an x to the first, two separate terms with x's, you're not going to be able to use the square root method. Sorry, I was looking for my eraser. So if you have the squared term and the x to the first term and you can't square root to solve, then you want to attempt to solve by factoring. So remember, when we're factoring, we want standard form. So we want the squared term, then the x term, and then the constant, everything in order and equal to 0. And then we factor. And the solutions are the values of x that make each of those factors equal 0. If we can make one piece equal 0, then we can make the whole thing equal 0. So what makes each factor equal 0 is going to be a solution. Okay? So 5 is ready to go here. It's in order equal to 0, so we would be looking for factors of 12 to make 13, which would be 12 and 1. And so this is going to factor into an 1x plus 12 and a 1x plus 1, which means one of our solutions is a negative 12, because that's going to zero out that first factor, and the other solution is going to be a negative 1, because that zeroes out that next factor. Okay? Not so bad. We can see in number 6, we're not equal to 0. We'd have to subtract that 4 over. So if we subtract that 4 over, since it's not a like term with anything, it's just going to be a 5x squared minus 8x and then a minus 4 equal to 0. And then 5 times negative 4 tells us to look for factors of negative 20 that make negative 8. Those two factors would be negative 10 and 2. And dividing by 5 and reducing, we can see this thing is going to factor into 1x minus 2 and 5x plus 2. And then we see our solutions. Positive 2 is going to cancel that negative 2 and zero that out. And on the second one, I would have to subtract the 2 and divide the 5. So negative 2/5 would be my second solution. And remember, if you're wanting to shortcut, the opposites of negative 2 here, the opposites are the solutions. So opposite of negative 2 would be positive 2. Opposite of positive 2 over 5 would be negative 2 over 5. So if that little shortcut is something that you want to continue to use, that still works. Okay? How about here? Here, again, we don't have a 0, so we want to subtract this x, but this time I have a like term to combine it with. So we're going to make this 15x squared minus 4x minus 3 equal to 0. And then we are looking for factors of negative 45. 15 times negative 3 is negative 45. Factors that make negative 4, like negative 9 and positive 5. And let's divide by 15. That reduces to negative 3/5. That reduces to 1/3. So this is going to factor into a 5x minus 3 and a 3x plus 1. And then my solutions, the first one, I'd add the 3 and divide 5. Positive 3 or plus 3 and divide 5 are my opposites. Zero that factor out. And then on the second one, a minus 1 and a divide 3. So positive 3/5 and negative 1/3 are my two solutions. Okay? And then one last guy here. Again, if you feel good about this, try it out. Here, I want to make sure, again, this is in order and then equal to 0. So 10x squared should be first. And then 10 times negative 6 is negative 60. I need factors that make 11. So let's see, I can use 15 and 4 and make the 4 negative. Those will add to 11 and multiply to negative 60. And then if I divide by 10 and reduce, 5 goes in there 3 times and twice. This is going to be negative 2/5. So this is going to factor into 2x plus 3 and 5x minus 2, making my solutions a negative 3/2, and then here a positive 2/5, which is again the opposites of the reduced fractions over there. Okay? So I know so sorry guys. Where did I go? All over my iPad. I went a little quickly on this last part here, solving by factoring, but that's technically review. So feel free to rewind and play it in slow-mo if I went a little too fast. Anyway, you've got some practice to work on. The newer method is the square root method. Luckily, we have ways to check our work if we really need, but I think it'll be okay. There are two other methods we're going to look at for solving that will come up in the next topic, and one of them is like a way to solve any quadratic. So, if all the methods that we look at aren't things that you necessarily like or want to use, there's one way that we can solve all of these things. So, things to look forward to. In the meantime, work on your practice, and if you need any extra help, then just reach out. All right, take care.